Hello everyone, it's Dr. White coming to you with another project. Before I get into the content, please make sure you like and share the video. Also, please ensure that you subscribe and check the bell notification so that you will be made aware of any future videos and live updates. When it comes to funding robotics programs in underserved communities, there are many systemic challenges and hardships faced in fundraising efforts. In underserved communities, access to resources and financial support for robotics programs is often limited compared to more affluent areas. This inequality stems from various factors, including disparities in wealth, institutional support, and lack of resources within. Thus, the need for fundraising efforts in underserved communities encounter significant hurdles, such as limited financial resources, lack of corporate sponsorship, limited networking opportunities, competing priorities, and resource allocation. Many families in underserved communities have limited disposable income, making it challenging to contribute financially to robotics programs. As a result, fundraising efforts often rely heavily on external grants, sponsorships, and donations. Companies and businesses may be less inclined to sponsor robotics programs in underserved communities due to reduced visibility and alienation of community partners, perceived return on investment. Corporate social responsibility initiatives focus more on affluent areas. Access to networks and connections that can facilitate fundraising, such as alumni associations, local and community NGOs, may be limited in underserved communities, further impeding fundraising efforts. Families and community organizations in underserved areas may demand prioritization of basic needs such as food, housing, and health care over extracurricular activities like robotics programs, making it difficult to garner necessary support. Educational institutions serving underserved communities often face budget constraints and competing demands for resources. This often results in funding for extracurricular activities such as robotics programs being deprioritized in favor of essential academic programs and services. Addressing inequality and inequity and funding for robotics programs in underserved communities requires systemic change, including increased investment in education, targeted support for STEM initiatives, and equitable distribution of resources. By recognizing and addressing these challenges, stakeholders can work towards ensuring that all students have access to high-quality robotics education, regardless of their socioeconomic background or geographic location. Donors will be asked to support our team or other robotics teams, and if they are going to support, then they would press a button, and you can see when they press the button, my limit switches are activated, and depending on the level of support, then that will determine how much information they are given or if they will receive a certain amount of treats. Combination circuits combine elements of both series and parallel circuits to create more complex electrical configurations. These circuits typically involve multiple branches with components arranged both in series and in parallel. Analyzing combination circuits often involves breaking down a circuit into simpler series and parallel sections, calculating the total resistance, voltage, and current for each section, and then combining the results to understand the overall behavior of the circuit. In a combination circuit, some components may be connected in series, meaning they form a single pathway for current flow. When batteries are wired in series, they are connected end to end so that the positive terminal of one battery is connected to the negative terminal of the next battery, and so on. This creates a single pathway for current flow, with the voltage of each battery adding up to produce a higher total voltage. For example, I have two 1.5 volt batteries wired in series. The total voltage across the circuit will be 3 volts, 1.5 volts plus 1.5 volts. Wiring batteries in series can be useful for powering devices that require higher voltages than a single battery can provide. In this case, I have LEDs that have a higher voltage requirement. I have green, red, and white LEDs that require approximately 3 volts each. Other components may be connected in parallel, providing multiple pathways for current flow. In a parallel circuit, all components are connected across the same voltage source. This means that each component experiences the full voltage of the source. This is an example of my wiring diagram, and this is an example of the circuit that I have in my project. As you can see, I used a multimeter to gauge the total resistance, and here shown is the total voltage in my circuit. Parallel circuits offer an advantage in this configuration. In parallel circuits containing bulbs or other resistive loads, each bulb shines with its full brightness because it receives the full voltage of the source. Contrastingly, in series circuits, the brightness of bulbs decreases as more bulbs are added due to the shared current. In this parallel circuit configuration employing 3 volts, the 3 light-emitting diode bulbs, and 3 switches, each LED bulb is connected to the power source in an independent branch. This arrangement ensures that the voltage across each bulb remains constant regardless of the status of the other bulbs. If one component fails or is removed, the others continue to function unaffected. The switches, serving as individual control mechanisms, allow for selective activation and deactivation of each bulb, affording precise control over the illumination output of the circuit. Thank you for watching my video, and please make sure you like before.